Hello, this video is going to take you through some calculator strategies when it comes to graphing. So first of all, we need to talk about what all the zoom features are in your calculator. Here I have an equation in y equals, I just made it up, and when you go and you zoom, you should always start with zoom standard. Zoom standard puts you on your normal from -10 to +10 block. And it's nice because from a previous question, your graph might be messed up. So always start with zoom 6 to start with a fresh graph. Now, if you want to see the maximum or the minimum on the graph, you can go and you could use zoom in or zoom out. That would work. Or you could go and adjust it in your window by hand. Like if you want to see higher, you go to window and up would be the Y maximum. Maybe pick a Y max of like 20 and you could graph again. But if you don't want to do it on your own, there are some other features other than just zoom in and zoom out. You could use zoom 0, for example. What zoom fit does is it takes your X values, and our X values are from -10 to 10, and it will adjust the Y values to see the max and minimum within the given domain that you chose. So it's going to go from -10 to +10 here, because that's what I have it set at, and zoom fit. It doesn't always give you the best graph, but now you can actually see where your maximum is. And I didn't have to, play around with the zoom in and zoom out or do it by hand. There's some other features in your calculator, such as zoom trig if you're doing graphs. Make sure you're in radian mode for that. And it just gives you a nicer trigonometry graph. There is also zoom stat. Now, what zoom stat is if you go to stat, edit, and this is sometimes helpful for regression so you could see how your equation is. You could have your coordinates in L1 and L2, and if you want to see how they're plotted out, you have to turn the plot one on, and you're going to go to graph, and you are going to see nothing because I did not start with zoom 6. But even at zoom 6, I don't see the coordinates. So zoom stat is really nice because it will adjust the window for you to see the coordinates that you just have. Just if you do use this feature, please turn off the plot one. You can never have anything highlighted up top. It will cause an error for you sometimes with graphing. So now actually looking at the tips, we have tip number 1. If you need to find an intercept. So do I need the calculator? Here we go. If you need to find an intercept, remember you are always looking for when the opposite variable is 0. So for example, if you're looking for y-intercepts, check where x is 0. X-intercepts, check when y is 0. Now, visually, it is very easy to find on a calculator. The only issues with a calculator is how do you know where you're actually looking? Like, how do you know that this is not 0, -8 and not 0, -8.1? How do you know this is 2, 0 and not 1.9, 0? So it's hard to get a definite answer from a graph, which is why we like to use the table. So if you're looking for an x-intercept, notice that the y is 0. And the x-intercept would be 2, 0. And if you're looking for a y-intercept, you want x to be 0. Your y-intercept would be 0, -8. It's helpful to compare your answers from the table to the graph. And that's because sometimes people switch up x and y intercepts. So just visually make sure the coordinate that you're choosing is actually on the x-axis or the y-axis. Oh, also, if you do not happen to see the x-intercept in the table, like let's say there's no y equals 0, what you can do is put y1 function, like let's say your function is x squared plus 2x, and then you could put in y2, y is equal to 0. From there, you just find the intersection with second trace intersect. You don't actually have to go and solve it on your own. Anyway, let's go to tip 2. If you need an asymptote, because this one is a pretty common question on the Regents. So for exponential equations, that is the equation on the left. If you want to figure out what the asymptote is, visually, you can kind of see it. Cool. I did not draw a straight line, but hopefully you could kind of see that it goes through the line y equals 3. A lot easier to see it on the table. It's where you are repeating. So the thing with this is that you're not actually 3, and please don't touch 3 when plotting the graph. You get very close to 3. The calculator just rounds to 3, but you're not actually at 3. Now notice how the 3 is on the side of the y value. So the asymptote is y equals 3. When looking for your, also, it's the vertical shift. Now, when dealing with logs, it's kind of where the calculator stops, doesn't graph logs properly. So it's kind of looking like it's stopping at x equals -2. How do I know that? Because I see that it is a shift to the left. But on the table, it's a lot easier with the calculator. Your asymptote is the first error. Now, you see how the -2, the number you're looking at, is in the x column? That's how I know the asymptote is x equals -2. Y equals are horizontal lines. X equals are vertical lines. It's opposite what you would think, just like intercepts are opposite what you would think. On to tip 3. If you need to find a maximum or a minimum of a function. Now, this is the hard one, and this is the one that you are going to want to use the calculator for. So you're going to put your equation in y equals, I'm just going to show you guys. Okay, you have your equation in y equals, and don't just sit there, actually put it in and make sure you can do this. From there, you're going to go to zoom 6 because you want to make sure you have a normal graph. And then you're going to see that you don't have the top there. So you could either do zoom 0, or preferably, I just like to adjust my window a little bit. So I'm going to go to window. I'm going to put the maximum to be at 20. I graph it. That is what I prefer. Once you actually visually see the maximum, now you could go and find it. So we have second trace. We're used to second trace intersect, but there's second trace min, and there's second trace max as well. So what we're looking at is second trace maximum. Now it's going to ask you for a left bound and a right bound. So here is your maximum, right? Up top. You're going to go to the left of it for your left bound. And it's going to put a little line there for you. Now it says right bound. So you're going to go to the right. Doesn't really matter where, just be to the right of the hill. And enter. Now you should have 2 lines. These are called boundaries. Your lower bound and your upper bound on the right. Your maximum needs to be within your boundaries because this tells your calculator to find the maximum value between these 2 walls. And it says guess. Honestly, you can ignore the guess. It's not very helpful. So you choose left bound, you choose right bound, you hit enter, it finds the maximum for you. And this is what I have down here. So keep in mind, your maximum is not what I circled. Your maximum is 12.25. The minimum, or rather, I don't know why I'm saying minimum, sorry, your x value is the location of the maximum. So pay attention to what the question is asking. If they say find the maximum, y value, the height. If they say where is the maximum, That's the x value, the location. Moving on to tip number 4, and I think there's only 4 tips. Yep. So tip number 4 is if you need to match an equation to a graph, whether they give you an equation and say, what's the graph, or they give you a graph and say, what's the equation? You're going to put all your answer choices in y1, y2, y3, and I feel like I cut off y4 accidentally. Is it under here? No, I don't know what happened to y4 at all. It disappeared. Good thing it's not the answer. So, oh, I see. The first one got cut off. Oh, all of this is supposed to go in y equals. And if you go to y equals, clearly you can't be on your standard window. You can't go from -10 to +10. And you can't really do zoom trig either because you're still going to get a bunch of squiggles. You specifically want to make your graph look like the graph they gave us. And what that means is that you have to adjust the window. So if you go to your calculator, the window button on the top left, you need to adjust these values. You're only going to touch the x min, the x max, the y min, and the y max. And how we're going to actually figure that out is x values are left to right. This graph is starting at an x value of 0. It's ending at an x value of pi. Now, that's going to be your x min and your x max. Be careful, that pi is not going to stay. I'm assuming your calculator is going to make it 3.14. So it'll go away and you'll have the decimal, and that's fine. Now you need your y values. The smallest y value is your y minimum, which in this case is -1/2. Your largest y value actually, you could do -1/2 to +1/2, but what I have my graph set on looks like I went a little higher. I went from the very bottom. So I went from y min is -1 to y max is +1. But either will work, it doesn't matter. And what this does is by changing these 4 items on your graph, this is annoying, those 4 things, you're going to create a box for yourself within your y min, y max, x min, x max. And that's going to be the window that you should see exactly. So you're going to put these all in the calculator and you're going to see which one gives you that exact window. I already have them all out, so you don't have to do it. Maybe double check to see that you're getting the same thing as me. If you're not, maybe you're not in radian mode. But the point is that the first one happens to match, the others don't. And please make sure you actually change your window because they tend to put a dummy answer that looks correct before changing your window and is very wrong after you change your window. So your answer key is uploaded. I put it in OneNote in the key section under review, but I do want to talk about very quickly number 1. Because in number 1, it says as x increases from 0 to pi/2, the graph of tangent will do what? And we haven't done tangents in a long time. So it actually says 2 tangent x. And I'm in radian mode. It says on the top right of my calculator screen. I'm going to go to zoom, and I'm going to go to zoom trig to see a nice graph of tangent that has many asymptotes. So it specifically wants to know from 0 to pi/2. Why am I looking at the whole graph if I just want to know from 0 to pi/2? This is your x min, this is your x max. I'm going to go to my window. X min is 0. X max is pi divided by 2. And it looks nice now, but as soon as I enter, that x max is going to turn into a decimal. And now I'm going to graph. And as I am graphing it, I'm noticing that maybe I want to see what's happening upwards a little bit. So I'm going to go back to window. And I'm going to make my y max, I don't know, let's go with 20. Now I can see what's actually happening on the graph. First of all, I can see that you are decreasing. And on the left side of this graph, yeah, I do start with 0. On the right side of the graph, I do not end with 2 because my x max is 20, y max is 20. And if you look, I surpassed 20. So because of the asymptote, we actually say it increases without limit. It means it goes up forever. But even if you didn't know that, at least you know that you passed 2. I really want to get to 3, but I might as well just do 2 really quick. Increasing means you're going up. Picture it like a roller coaster from left to right, because that's the direction we read. Down the roller coaster, up the roller coaster, down the roller coaster. So it's talking about increasing. We specifically increase from here to there. This section is increasing. Now that is from, I can't read that. What is that? -4 to 2? I guess I read that wrong. -5, there we go. Okie dokie. 3 is what I wanted to talk about. You have the temperature of a cooling liquid in a room held at a constant 75 degrees Fahrenheit can be described by the equation that, where F is the Fahrenheit temperature and T is the amount of time it has been cooling in minutes. Which of the following is the original temperature when it began cooling? Sorry, I'm distracted because there's Mr. Softy outside and I want ice cream, but I will resist. Anyway, original temperature is when T equals 0. Original means to start with, before any time has passed. Now, unfortunately, in the past, I have people who jump to conclusions. You can't just assume something disappears. You need to make sure you actually know what you're doing. And the way to make sure is to use a calculator. So you can plug in 0, absolutely. You can put it in y equals. You can go to the table at 0, what do you get? But I have a lot of people who do this in their head. Because of that, they lose points. Please don't lose points. So put in the calculator, see what you're going to get. Ooh, it looks like 207 to me. And if I'm not right, I should have used the calculator, but pretty sure I am. Try to do your best when working through the rest of this packet and use the calculator even if you don't want to. Hope it helped.